My name is Radhika Rangarajan. I'm with Intel Big Data Technologies, and I will be talking to you about deep learning solutions powered by Intel and BigDL. So what is BigDL? BigDL actually stands for Deep Learning for Big Data. It's basically a distributed deep learning library for Apache Spark. BigDL is implemented as a standalone library on Spark. Now, we actually worked on this for about a year, and we actually open sourced it towards end of 2016. So the project has been out there for about 9 months, and we've seen tremendous support from the community, from customers, and from the cloud service providers. If you're familiar with a Spark stack, you know that there's a Spark core, which is a core data processing engine, on top of which there are libraries for SQL processing, R, stream processing, machine learning, graph analytics, and so on. We built BigDL to reside alongside with these other libraries right on top of Spark core, and works really well with Spark machine learning and data frames. With BigDL, users can build their deep learning applications as standard Spark programs, which can then run on their existing Spark or Hadoop clusters. So very often we get asked the question, what can I do with BigDL that I cannot do with other deep learning frameworks, or why do we need another deep learning framework? Well, the reality is that if you look at the Hadoop Spark stack, there is a key gap in terms of not having an organically built deep learning library that takes advantage of the massive scale of the Hadoop and Spark ecosystem. So to address that gap, we actually introduced BigDL. From a feature perspective, anything that you can build with traditional deep learning frameworks like Caffe, Torch, or TensorFlow, you can build with BigDL. So it has feature parity with all popular DL frameworks. The fact that BigDL actually runs on Intel Xeon on your existing Spark and Hadoop infrastructure, you can take advantage of your existing investments. Now, for IT and infrastructure managers, that means lower TCO and improved ease of use, because now you're working with a software stack that you're already familiar with. BigDL actually is built on for Intel Xeon processors, which means it takes advantage of Intel's math kernel acceleration library. So you get high performance from the single node acceleration from Intel's MKL. Now, when you're talking about Spark architecture, it becomes less interesting when we're defining single node performance. BigDL actually takes advantage of the sufficient scale out architecture of Spark and scales to tens to hundreds of Xeon processors. Let's look at what's inside BigDL. Now, beyond the basic layers that you can, there's like 100 plus layers in BigDL that you can use to build any kind of models. But beyond that, the fact that BigDL is actually built for Spark, it's built in Scala, so you have both Scala API support, and we recently introduced Python API support as well. It integrates really well with Spark machine learning and Spark streaming. And there's some excellent use cases and code snippets available on the GitHub on how to actually leverage BigDL to work with these other Spark components. With our version 0.2 that came out in second quarter of this year, we actually provided Jupyter Notebook integration for BigDL. Now, the interesting part about deep learning is the time you spend training your model and actually ensuring your model converges. This would actually be very much of interest to all the data scientists, because we now have TensorBoard integration with BigDL, so you can actually do visualization of your entire training cycle. And last but not least, and this is one of the most appealing features of BigDL, interoperability with other traditional deep learning frameworks. You can actually load Caffe, Torch, or TensorFlow models inside BigDL and continue to fine-tune them. Now, where would you want to use something like this? It would be in inferencing as well as in transfer learning. With a version of BigDL that's coming out in October, we are going to be able to provide some amount of functional API support for working with some of the popular deep learning frameworks, as well as Keras support. So what has the community cloud and customer adoption for BigDL been? I mentioned earlier that we open sourced it in December of 2016. We have seen rock solid community support. When I actually open sourced this, we had about a handful of contributors to this project from Intel. We are trending at about 37 contributors at this point, all of them external. So that tells you how strong a project is and how it can sustain on its own as a community-driven initiative. But let's look at all the cloud and partner support. Now, we know that all popular CSPs have their version of managed Spark services. BigDL is available on all your favorite cloud platforms, from Azure HD Insight to Azure DSVM to Amazon Web Services to Kingsoft Cloud, which has recently included BigDL as part of their managed MapReduce service, and Databricks. All the CSPs have technical tutorials and blogs available on how to onboard BigDL on their platform. Cray is a very valued partner for Intel, and as a supercomputer company, when you talk about scaling on Spark, Cray knows how to scale to hundreds of nodes. And Cray has actually integrated BigDL within their Eureka XC platform and shipped it out just a couple months ago to all their HPC users. Both Lightbend and Cloudera are also valued partners, and they have actually put out BigDL-based technical blogs and tutorials. Now, with Cloudera's data science workbench, you can easily bring in BigDL into that environment and continue to work with your familiar CDH environment. We are also working with Cloudera on a tighter integration of BigDL to simplify the experience of working with BigDL inside the data science workbench. We just announced this morning, or actually Blue Data announced this morning, that they would be actually integrating BigDL with their fall release of Epic. Well, who is productionizing with BigDL? And that's the more interesting part. From what I can actually tell you, from finance vertical all the way to healthcare, we have several proof points, all of whom have actually built end-to-end use cases, productionized solutions with BigDL. Now, in the past talks, we've talked a lot about the fraud detection use case that UnionPay actually implemented. I want to shine the spotlight on the other 3 use cases. Very briefly on the healthcare vertical, we partnered with the Center for Digital Health and Innovation at UCSF, and they have actually implemented a use case for automatic knee damage detection and classification using 3D MRI models with BigDL. But the next couple of slides, I'll go a little bit in detail about the use cases that JD.com actually built, as well as with Gigaspaces. So what did JD actually build? Now, if you don't know, JD is one of the top online retailers in China. And to put it in context, they have hundreds of millions of merchandise pictures that they like to actually analyze and do some feature extraction at a large scale. Feature extraction, image feature extraction is a very complicated problem because you first need to identify whether the object of interest is available in that overall picture. And then you have to extract the features of the image. So it's actually a 2-stage process. You have object detection, and then you have feature extraction. So what we did was we used the single-shot multi-box detector model for object detection, and we used the deep bit model for feature extraction. And all of this was done with BigDL. Before JD actually leveraged BigDL for building this inference pipeline, they were using Caffe models on GPU clusters. And with the performance and throughput that they were getting out of this BigDL-based model, they have now decided to move to the Intel Xeon processor family. So the pipeline is very simple. You have hundreds of millions of images in your distributed data set. You actually read them as Spark RDDs. You pre-process these images, and then you actually use BigDL to load the SSD model, and you do object detection on that. Once you have identified the object that's of interest, you isolate that object based on its coordinates, and you crop the image. And then you resize the image, and you batch it again, just a little more pre-processing, and you use the deep bit model to extract the features out of this target object, and you put it back in HTML. There will be a white paper alongside with this use case that you can read about later. Now, here's another interesting use case, customer service call center experience. How do you actually simplify that experience with BigDL? Gigaspaces and in-memory computing Insight Edge platform has now integrated BigDL to automatically transcribe your customer service request, analyze the text, and route it very efficiently in less than 100 milliseconds to the respective specialist, tech specialist, who can actually quickly respond to your call. So those are just a couple of examples. We just launched BigDL on AWS Marketplace. So I would highly encourage everyone to go and try BigDL from AMI from the Marketplace. And you can actually get free compute credits if you want to try that. So do get started with BigDL. Here are a few resources that are available. You can apply for free compute credits for BigDL for trying this on our Marketplace and join the conversation on our user group. But I want to leave you with one more thought. In addition to BigDL, Intel is heavily invested in optimizing all other AI frameworks, and we have a wealth of information available on the Intel Nirvana Academy, from trains to tools to community. So Thank you for joining this talk on BigDL, and hope you get to join the conversation with us in our user groups.